The Western Interior Seaway, which was which is also called the Cretaceous Seaway, the Niobrarian Sea, the North American Inland Sea, and the Western Interior Sea, was a large inland sea that existed during the mid to late Cretaceous period, as well as in the very early Paleogene. It split the continent of North America as we know it today into two separate land masses, one which was Laramidiato, which was to the west, and Appalachia, which was to the east. The ancient sea, it stretched from the Gulf of Mexico and through the middle of the modern day countries of the United States and Canada, and it met with the Arctic Ocean up in the north. At its largest, it was 2,500 feet deep, 600 miles wide, and it was over 2,000 miles long. Now, widespread carbonate deposition, it suggests that the seaway was warm and tropical with a large amount of algae. When looking at the sea itself, stratigraphical and sedimentological analysis has revealed a lot about the detailed history of the relative sea level change of the Western Interior Seaway. What stratigraphy has to do with, for those who are unfamiliar, is rock layers called strata and the layering of those layers, which is called stratification. This method is widely used for a variety of purposes. For example, much of our present knowledge of stratigraphy and near surface stratigraphic sequences comes from subsurface drilling and exploration, which is funded by energy companies looking for subsurface oil and gas. This relationship between the science and commerce has been beneficial for both parties, as it allows oil and gas companies to see improved profits, and it also allows for the advancement of geology at a faster rate than would occur if the research was just carried out by other groups of people. The relationship has caused petroleum science to evolve from an undeveloped geology to supercomputer based calculations, which that drastically changes the focus from a guessing game to a concise matter, a sort of a formula to target different sources of natural energy within the Earth. Other scientists have used field evidence to model the large scale effects of tidal waves that entered from the south. Researchers have collected field data from areas where the sea would have existed in Utah, Colorado, and Wyoming. The data that they used was used to calculate that the tidal currents strongly influence the regressive segments of many deltaic cycles, which are sites where low relative sea level caused the seaway to narrow and it caused the seaway to be restricted up to the north. They also determined that the influence of the tide was fairly strong during the development of many different shorelines at the time. Now, there were many different life forms that existed during this time period where the Western Interior Seaway existed. When you're looking at the life forms that existed in the area, um, it is important to understand that what researchers use to determine what life forms existed. Researchers use geographic information systems. The University of Kansas um, paleontologist named Corinne Myers and her co-authors used geographic information systems analysis to estimate the ranges of marine mollusks based upon where their fossils had been found. This helped them understand how species invaded new habitats and went extinct during the late Cretaceous period. From stage to stage, the researchers they tracked the expansion and the contraction of ranges during the last 35 million years of the Cretaceous period. What those ranges had to do with was how far certain species of life forms spanned in the western interior seaway. And what they found is that specifics, uh, species that existed in one centralized location were able to survive more easily as they were able to proliferate across the western interior seaway, whereas the more generalist species did not survive as well during the time. As for the actual animals that existed, diverse marine life existed, and that marine life included sharks, marine reptiles, and large bony fish. The mud bottom of the sea was fairly flat, it was soft, and the sea itself was oxygen depleted, which allowed fossilization to happen easily. Fossils of early giant birds and the giant clam called Inoceramus have been discovered in the western interior sea, and scientists believe that the giant size of this Inoceramus fossil was an adaptation for life in murky bottom waters, where a large gill area of the animal would have allowed the animal to survive in the waters which were depleted of oxygen, as I have already stated. Now, much of the previously mentioned research was used to construct models referring to what the western interior seaway would have looked like and how animals traveled, but none of the sources dealt with the factors that formed the seaway and the factors that caused the seaway to cease to exist. Ron C. Blakely and his colleagues, they were a group of people who figured out how a subducted slab eventually increased the vertical elevation, or the uplift, of the Earth's surface. They figured out how this vertical elevation caused the division of the western interior seaway into laramide uplifts and basins. And they discovered how it led to the withdrawal of the western interior seaway. They were able to make these conclusions by preparing paleogeographic maps for tightly spaced periods of time. Now, what these paleogeographic maps were is sort of showing the varied landscapes of the western interior seaway, and the seaway was created. They determined by using these maps that the seaway was created when the Farallon and the North American tectonic plates collided. The Farallon plate is a plate that no longer exists, but we know today that the North American plate exists. And this collision allowed the waters from the Arctic Ocean to the north and the waters from the Gulf of Mexico from the south to meet and form this seaway, which flooded the central lowlands of what we know as North America today. And it formed the sea that would both transgress and regress during the Cretaceous period in many different cycles. But at the end of the Cretaceous period, continuing uplift in mountain building formations, especially the mountain building formation known as the Laramide orogeny, lifted the sandstone and shale, while low-lying basins between the spaces of the sandstone and shale and the space of the basins was gradually brought together. The western interior seaway was divided across the Dakotas, and it retreated towards the south of Mexico. This shrunken regressive face is sometimes referred to as the Pierre Seaway. And this seaway is determined to have existed between 82 and 69 million years ago.